Here's our first equation. Now, the first time people see something like this, they oftentimes get confused and worried immediately. And the reason is often because we are uncomfortable with seeing letters, multiple letters, in this case X and Y, in the same kind of situation with an equal sign. Now, because there's an equal sign, this is an equation. The word equation means there's an equal sign. So what this is basically telling you is the variable y, which we put it in the output column here, is equal to whatever the input here. See, x is labeled as the input. Whatever the value of x is, we put it in here and we add 1 to it, and then that is assigned the value of what y is. So the best picture that you can really do for yourself is you can imagine this equation of a line as being like a box. So on the input side of the box, we feed in. These are the inputs, right? And the box does a calculation. And the output here is y is equal to x plus 1. So you can think of, and this is the output. You can think of the inside of this box as being equal to, y is equal to x plus 1. There's a calculational engine going on in there. You can think of it as being a computer. You can think of it as being little gerbils, calculating something with pencil and paper. Some kind of like calculational thing going on in there. You might say that it's a function going on inside of there. A function being a calculation. We're going to talk about functions a little bit later. But for now, I want you to just think about this box being like a little calculational engine. It takes any input number in, it does a calculation on it, and it assigns the output to the variable y. So this table is inputs and outputs. Now, you can pick any numbers you want for the input. Here, I've picked 0, 2, 4, 6, and 8, and we're going to use those to plot, but you could pick any number you want. You could put -5 in there for the input. You could put 1/2 fractions for the input. You could put 0.65 decimals for the input. They don't have to be whole numbers, but whole numbers are easier to calculate with, right? Because we can see that if I take the number 0 for x and I stick it in the position of x, then I have 0 plus 1. And then the output must then be equal to 1. You see the input goes in, I calculate something, and then the output is assigned to the letter y. Now, if I take the number 2 and I put it in here, then 2 plus 1 is 3, and 3 would be assigned the value of y. If I put 4 in, then 4 plus 1 is 5. 5 is assigned to the value of y on the output. If I put 6 in, 6 plus 1 is 7. If I put 8 in, 8 plus 1 is 9. And so here I have all of these now points. I have actual x, y coordinate points because the x values are given here, and the y values I have calculated. So you can see that the outputs, the y, are dependent on whatever we choose to put for the inputs. So you could say that this y value, these are called the dependent variables because they are dependent. The y is dependent on whatever I choose to put in for the x. It's like throwing baseballs. I can just throw them all day at the batter, and the batter is going to try to swing. But these throwing the baseballs, these are the inputs. The output is when the person tries to crack at the ball, right? But those pitches, every pitch is a little bit different. So every number that I put in to this little calculational box, which later we're going to call a function, is just calculating based on the input. So the input is the independent variable because that's what it's not dependent on anything, but the output, it is dependent completely on what input comes in the front end of the thing. So here I have inputs and outputs, and now I can form points with these guys, right? So this one will be 0, 1, x, y. This will be 2, 3. This one will be 4, 5. This one will be 6, 7. And this one will be 8, 9. So what we're going to do is we're going to plot these points here, all right? So the first point is 0, 1, and I'm not going to plot for every single one of these, but in the beginning we'll do the first one. 0, 1 means x is 0 and y is 1, so there's a point that goes right there. 2, 3 means 2 for x, 3 for y, which is right here. 2 for x up to 3 for y. 4, 5 means 4 for x and 5 for y, which is right here. And then 6, 7 means 6 for x and 7 for y, 6, 7. And then our last point was 8, 9. So 8 is here, and then 9 is right here, right? So we have a point right here. Now, if you grab a straight edge, you can see that these do form a line, a straight line. It's not curved in any way at all. And I have a prettier version of that already constructed here. You can see this line here is exactly the same as the line that going through those points. It's just nicely drawn. Notice the line comes down here and it cuts into the y-axis right here. Same as here, the line cuts in at the same exact position, and it goes up and it stops up there as well. Now, how do we know this is a line? Well, you can take a look at this, and one way to know it's a line, obviously it looks like a line, is to just take a look at the slope. We know that all lines must have a constant slope. No matter where you look on the line, the slope is the same. So how do we find the slope between these points? Of course, we could calculate it. We could, subtract the y and subtract the x and divide, or we could just look at it and say, well, rise over run. Here is 1, 2, and here is 1, 2. So the rise is 2 and the run is 2. So it's 2 over 2. And so we've learned how to calculate slope before. 2 over 2 is 1. So the slope of this line is the number 1. And so if we go from this point up to over 2, again, 2 over 2 is 1. Slope is 1. Up 2 over 2, slope is 1. Up 2 over 2, slope is 1. So the slope of this line is 1. I'll just go ahead and put it here. The slope of this line is equal to 1. The main point of this lesson is actually not to talk about slope and all that. It's mostly just to show you how to plot these things. But we're going to be connecting the dots very soon with the equation of a line and kind of like getting a little more general. So I want to take the opportunity, since it's such an easy problem, to show you what we can learn from it, okay? So we know it's a line because it has a constant slope everywhere. It doesn't curve or bend or anything like this. We can calculate the slope by just looking at the graph and taking rise over run. We could pick 2 points and subtract and divide. We'll get the same thing. In fact, you can see 3 minus 1 is 2. For the y values, 2 minus 0 is 2. 2 over 2, of course, is the slope of 1. All right? Now, I want to take a minute to point out the general form of the equation of a line, right? Now, in our case, the equation of this line is y is equal to x plus 1. It turns out that all lines have a very similar, in fact, they all have the same exact general form. All lines, no matter if they're pointed this way or this way or this way or this way or this way, they all basically have the same general form. And since lines are so important, we're going to learn what that form is. And you'll be able to recognize, hey, that's a line just by looking at the equation. Even before you plot anything, you'll know it's a line. Let me show you how. And we're going to do a lot more of this in the next lesson. So all lines have the following form. Y is equal to m times x plus b. Notice there's no numbers here. So we're going to compare this with what we know that this thing predicts and draws out a line as well. The variable y is equal to m. M is the slope of a line, of the line. So this is the slope. Times x, but m is a number. M is just a number called the slope. And then b right here, this is called the y-intercept. I'm going to put y-int, y-intercept. So let's take a look if this makes sense. In our equation, we have y equals x plus 1. Okay, it kind of looks like it's the same form. Okay, so notice that here, the b over here, in our equation of our line is equal to 1. So this means the y-intercept is 1. The y-intercept is the place where the line crosses the y-axis. So notice that our line comes down here and cuts it right here at y is equal to 1. And that is precisely because we have a 1 right here. The y-intercept, when you have an equation of a line, y is equal to something times x plus a number. This number is always going to tell you where the line is going to cut through and hit the y-axis. In this case, it hits it exactly here at the number 1, at y is equal to 1. All right. Now we have the letter x. And the coefficient in front of x is always the slope. But in our case, there really is no obvious coefficient here. But when you think about it, all variables have a coefficient of 1. So even though it's not written here, this is basically the same thing. This is the same thing as thinking about it like this. Y is equal to 1 times x plus 1. This is really the same exact thing. The coefficient sitting in front of the x is just a 1, so this means the slope is 1. And that's what we just found, right? We just wrote it down. The slope is 1. Rise over run, rise over run, rise over run, rise over 1. It's 1, it's 1. The slope is 1 always as we go across this line. So we're going to work more problems. The main point of it isn't necessarily to focus on this. The main point of it is to think about any equation like this. And of course, we're talking about lines now. You have an input and an output. The input always goes into the x position. We calculate some number. The result of that calculation gets assigned to the variable called y. It's just like a machine. Inputs go in, outputs of the calculation are assigned to the variable y, and they come in the output. Once you have an input-output table, you can write down the points x comma y, and then you plot all the points x comma y, and you draw a line through them. All right? In this case, we know it's a line because we can look at it and we can calculate the slope of this line. And then we said, hey, all lines, any line you could possibly think of, even lines that go the other way, they always have the same form. Y is equal to m, which is a number called the slope, times x plus some other number called the y-intercept. Whatever number lives in front of x here is called the slope. In our case, the slope was 1, and that's exactly what our equation predicted. And whatever number comes after the plus sign is called the y-intercept, and the y-intercept is where the line cuts through the y-axis there. So if you know the y-intercept and you know the slope, you can trace out the line right there. And the last thing I'll leave you with before we actually go and solve the next problem, why does this letter here, why does this number here predict the y-intercept? Why does that predict it? Well, it's because if you put x is equal to 0 in here, then 0 is going to be, when you put the value of x is equal to 0 in here, all you have left is 1, so y is equal to 1, right? And that's why it cuts right here. So that's why the number that you have to the right of the plus sign always gives you the y-intercept, because if I ever put a value of x is equal to 0 in here, it's going to kill this and make it go to 0. Whatever is left over, y is equal to whatever this is, that's going to be where it cuts. We call that the y-intercept. So a lot of big ideas here. Let me take this down. Let's go to our second problem, and we're going to practice, number 1, plotting it, and number 2, understanding why the equation has to be a line, because the equation of all lines have the same exact form. So let's do that next problem right now. All right, let's take a look at problem number 2. Here is our equation, and you are, I know, just getting used to this and introduced to this, but we know that this has to be an equation for a line. Why? How do we know this? Because all lines have the same form. The form of any line that you could possibly draw is equal to m, the slope, times x plus what we call b, the y-intercept. And it lines up exactly. There is some number, -2 times x, plus some number, in this case it's 6, and it's equal to y. Anything you see that looks like that, you know immediately it has to be a line. You're not sure if it goes this way or that way or what it looks like, but you know it has to be a line, always, all right? So let's draw this line by using an input-output table. Our equation is y is equal to -2x plus 6. And the first value of our table, we're going to choose any number we want, but 0 is nice. We're just going to put 0 in. All right, so what we'll do is we'll say what happens if x is equal to 0. Then y is going to be -2 times 0 plus 6. But you see, this goes to 0, and so y is going to be then equal to just 6. So y is going to be 6 when we stick a value of 0 in here. So we're going to have a value of 6 right here. Now let's put a value of 1 in here. Y is -2 times 1 plus 6. So what we get here is -2. And then we still have to add this 6 to it, and we're going to get a value of 4. Let me just double check myself. Yep, a value of 4 goes here. All right, let's take a value of 2 and stick it in here. For x, -2 times x is equal to 2 plus 6. Now this becomes -4, and then we have plus 6, and when we add these together, we get a positive 2. -4 plus 6 is positive 2. So we have a value of 2 here. When we stick a 2 into this equation, we get a 2 as a calculational answer out. Our last value here that we have in our table is 3. So we'll put a 3 in here. And what do we get? This is -6. So we have -6 plus 6. And this, of course, adds to be 0. All right, so now we have our table filled out of input and output values, and this forms a point, 0, 6. This forms a point, 1, 4. This forms a point, 2, 2, and then we have 3, 0. Still difficult to tell if this is a line or not, so let's go and actually draw it. So we have 0, 6. So 0, 6, 0 for x, 6 for y. And then we have 1, 4 here. I guess I'll go a little closer here. 1, 4, 1 for x and 4 for y. And then we have 2, 2, that means 2 and 2. And then we have 3, 0, 3, 0 right down here. And you can see just by eyeballing it, that this does indeed form a line because a line goes through all of those points. And I have a nice pretty version of this on the next chart here. You can see it goes through all the same points, 0, 6, 3, 0, 0, 6, 3, 0, and then the points in between. And so this is our nice line. Now the interesting thing about this one is that this line is slanted in the negative slope way. We've calculated slope before. We know that when a line is slanted this way, it has a positive slope because it's kind of rising with time, if you think about this in terms of time. But if it's going down like this, then we know it has to have a negative slope because it's going down. All right, so we know it has a negative slope, but it's still a line, right? Now let's rewrite what the equation of this line is. The equation that we wrote was -2 times x plus 6. So our equation was -2 times x plus 6. We know it's an equation of a line because it matches up exactly with this. Let's see if it makes sense. The y-intercept is predicted to be 6. That means the position where the line cuts into the y-axis is here at 6. And the slope of this line, whatever lives in front of x, whatever the coefficient is, we say that the slope should be -2. So we're going to write that down, and we suspect that the slope is -2. Why? Because we know this is an equation of a line, and whatever number lives right in front of x has to be equal to the slope. So we believe the slope is -2. -2 is a negative slope, so it's slanted this direction. And you can think of this as -2 over 1, right? Because you can write it as itself over 1. So if we start here at the y-intercept, and we rise down, because it's negative, down 2, and then over 1, because this is rise over run, down 2 over 1, down 2 over 1, down 2 over 1. It traces out this line exactly. So if you know what the y-intercept is directly from the equation of a line, and you just start tracing with a stair step using the slope, which is also given from the equation of a line, then you can obviously draw the line. So we're learning how to plot this line by creating a table of values and putting all the dots and connecting the dots. But I'm also showing you kind of in parallel here that very soon we're not going to make tables to draw lines. Very soon we're just going to use the equation of a line to draw the line, because directly from the equation we know the y-intercept. We can put a dot on the graph immediately where the y-intercept is. And then we also know the slope. So if we know that point, the y-intercept, we can just go rise over run from that point and trace out the line without making a table of values. So here we made a table of values. We can see that the equation of a line matches up with the equation of a line we know. We extract information from here, and we can prove to ourselves that the slope that we get from the graph is the same as the slope that the equation is telling us. And then that's basically the point of the lesson, learning how to draw lines, learning how to read them. So let's take it down. We're going to do one more. I do want you to pay attention to the next one. I don't want to say tricky, but it's a little different. So we're going to do that one right now. All right, let's take a look at our next problem. We have the equation y equals 1/2 times x. And I'm telling you that this is a line, but the first thing in your mind should be, well, wait a minute, this doesn't quite look like the equations of a line we've been doing before. mx plus b, it doesn't look the same. How do you know this is an equation of a line? Let's work through it. Let's plot it, and then I'll show you how it in fact does fall into that shape. It is a line. All right. So first, of course, I want you to think about these things as little functions. We're going to talk about functions later and the mathematical definition of a function is. But a function in computer programming is a little block of code that does a task. So this guy, taking the x inputs on the inside, and then we calculate the y is equal to 1/2 x. We do a little calculation here, assign it to the variable y, and then the variable y comes on the output. So this is the calculational engine. You can think of little hamsters or gerbils, a little calculating machine inside of there. Inputs go in, boom, 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 calculate, and then y values come out. So it's a stream of inputs and outputs, right? But in this case, it's very simple. It's 1/2 times whatever the input is. But if I stick an input of 0 here, 1/2 times 0 is just simply 0. And if I put a 2 in here, 1/2 of 2 is just 1. And if I put a 4 in here, 1/2 of 4 is 2. And if I put a 6 in here, 1/2 of 6 is 3. And I put an 8 in here, 1/2 of 8 is 4. And a 10, if I put it in here, 1/2 of 10 is 5. Now again, you are free to put any inputs you want. I could put an input of 3.96 in here and calculate half of it, but then I'll have decimals and it'll be tough to graph it accurately and all that. So I'm just choosing x values that are just nice, that are easy to calculate. 1/2 of 10, 1/2 of 8, 1/2 of, but if I had 1/2 of 7, If I put 7 for x, that's fine. I'll get 3.5, but then I have to graph 3.5, and it won't be exact because 3.5 falls in between. So usually you want to pick easy values. All right, so what I have is 0, 0, and I can plot that right here. 0, 0 lives right here. And then I have 2, 1. That means an x value of 2 and a y value of 1. And then I have 4, 2. That's an x value of 4 and a y value of 2. You can already see it kind of making a straight line. 6, 3. 6, 3 is right here. And then 8, 4. 8 for x, 4 for y, right there. And then 10, 5. 10 for x and 5 for y. All right, so I'll just hold up my little straight edge and just prove to you that these points do, in fact, form a line. And I have a pretty picture of that line on the next page. You can see this is the exact same graph. This point is right here. It goes down and it cuts right here. And we can verify that this is the case. So we have the line is traced out right here. Now, let's verify that. Let's take a look at this equation of a line we had. We graph the equation y is equal to 1/2 times x. Now this doesn't look the same, right? Because y is the same, 1/2 is the slope, okay, times x, but there's nothing here for b. And you're like, wait a minute, this isn't a line. Well, if there's nothing here, it's the same thing as just having plus 0. So yes, I don't have to write y equals 1/2 x plus 0, because if I have plus 0, I don't ever add plus 0. I can add plus 0 to anything I want. I can say that 5 apples is 5 plus 0. I can say that $25 is 25 plus 0. I never add the plus 0 if it's there because it's pointless. But to show you that this is the same form as this, I can just put the plus 0 there and you can see that the y-intercept must be 0. Look at this. The graph crosses where the y-intercept exactly at 0. Right? And then I can read the slope directly off of this. Look at the slope is 1/2. It's what is sitting right in front of x. So we're predicting that the slope is 1/2. Let's see if that's the case. If I start from here, 1/2 of a slope means rise over run. It means a rise of 1 and a run of 1, 2. Rise up 1 and then over 1, 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. So the slope of this is indeed 1/2, which is exactly what the equation of a line predicts. The y-intercept of this thing is 0. It cuts exactly where y is equal to 0, which is exactly what this predicts. And even if you cover this up, it doesn't look like this is an equation of a line. It is when you consider the full version of it where the y-intercept is 0. So in this lesson, we have done a lot, really. I actually did a lot more than I really intended to do in this lesson. It's just I can't resist connecting the dots a little bit, and I could maybe not do it, but in the next lesson, we're going to talk about the equation of a line and slope and y-intercept. But it's kind of like silly to not point it out now because it's so easy to understand and for you to start getting those gears turning early. The focus of this lesson was to show you what an input-output table is and to draw this picture and to show you that all of these equations, y equals anything, is basically a calculational engine. Later on, we're going to call it a function. But I don't want to get into function right now. It's not complicated, but you can consider a function. A function is something that does a task. Okay? The task here is to take the input values of x, cut them in half, assign those values to the output, which we call y, and then we take the x, y pairs, and we have now coordinate pairs, which we can then plot, and we see that this does form a line. And the slope of this line is up 1 over 2, so the slope is 1/2. And the y-intercept does indeed cut at 0. And it makes sense that the slope is 1/2 because this line is shallower than the lines we were doing before. It's remember, a horizontal line is exactly a slope of 0, and a vertical line is a slope of kind of infinity. And so this is getting down very close to horizontal, so it makes sense that the slope is almost, or less than 1. It's not really close to 0, but it's less than 1. All right? And then we write down the equation of a line and say, well, wait a minute, it doesn't look like an equation of a line, but it is when we reveal, we put a plus 0 there and recognize the y-intercept is 0, the slope is 1/2. And in future lessons, we're basically just going to look at the equation of a line and graph it without using this input-output table, because once you know the y-intercept and you also know the slope, you can trace out the line. That's what we're going to be doing soon. But the focus of this was creating that input-output table. We're going to use input-output tables later also because we have a whole world of graphs that don't look like lines. And the way to sketch them is to make an input-output table. Inputs come in, outputs are calculated and they come out the other side. We grab those points and we plot them. So I'd like you to graph all of these. Make sure that you understand how to make the input-output table, how to graph it. Once you have the graph, how to look at it and find the slope and the y-intercept, and how to look at the equation and pull out the slope and the y-intercept from the equation and verify that what you drew is in fact what the equation tells you the slope and y-intercept should be. That's what we're trying to do. Follow me on to the next lesson. We're going to do a few more problems here, and then we will continue your skills with slope and y-intercept and graphing equations of lines without using tables, but using only the equation itself. Learn anything at mathandscience.com.